Okay, let's look at the BC specific free response questions from 2025. This is question number 2. And I have not read the question yet, so you do not get a polished, rehearsed solution. So I may make mistakes, and if I do, please comment below and let me know. So you get to see me solve this in real time, how I process problems and think through them. This is a calculator active question, and it appears to be, it is indeed a polar question. So let's check this out. So we have the curve C defined by that polar equation for blah to blah, and we have a semicircle, R is 1/2, okay. Find the rate of change of R with respect to theta on the point, on the curve C. I was waiting, how do you know which R they're talking about? Okay, on the curve C, so that's the ugly one. At 1.3, show the setup. Oh, this one's nice. This is really nice. Okay, so despite this being a polar question, which some people tend to not like very much, I am going to go ahead and define R of theta, or write this down. That'll be 2 times sine squared theta. And that's for 0 to pi. And I think I'm going to go ahead and also go to my calculator and define that in my calculator. So let me clear this out. Doc B, that's stuff from another question. So I'm going to define R of theta. I'm just going to use X colon equals, and that is 2 times the sine of X squared. There we go. So that is now defined. And question A is asking the rate of change of R with respect to theta. So A, this is really nice. A, the rate of change of R with respect to theta at, that's not a theta, when theta is 1.3, is the exact same thing as R prime of 1.3. And with this being a calculator active question, I'm going to punch this straight into the calculator. This seems too easy. I feel like I'm missing something. All right. Menu, calculus, derivative at a point. I'm using my trusty Inspire here, and I'm plugging 1.3 into the first derivative of R of X, and I'm getting 1.0310. 1.0310. There's no interpretation, nothing. I don't like how easy that was, but onward we go. All right, number B. Find the area of the region that lies inside C but outside R equals 1/2, and I will need to know the intersection of those two graphs. And I'm going to pause the video and try to draw this really quick. The College Board doesn't like it when I screenshot the questions when I initially solve them, so I'm going to draw this really quick just to have a visual. Man, that would suck on the actual AP exam because y'all don't have it drawn on your paper. Stupid digital exams. All right, I'll be back in a sec. Okay, so here we go. There's my graph. That's pretty good. I used little shape tools to do that. So I want this area right here, inside C but outside semicircle. Okay, so I want this region right here. Okay, and so I'm going to take advantage of symmetry here. I'm going to do the area from this angle right here. I need to find out when those two cross. I'm going to find that angle, and then I'm going to go all the way up to pi over 2. And I'll double that. So this is going to be theta equals pi over 2. I'm pretty sure. Let me double check that. So if I plug in pi over 2, yeah, that'll be pi over 2. And so this angle is going to happen when R of theta is equal to 1/2. I'm going to go into the calculator and solve that. Do I need to do a calculator? So that's going to be sine squared theta is, no, this isn't going to be too bad. So, so that's 2 sine squared theta equals 1/2. That's when sine squared is equal to 1/4. The square root of 1/4 is 1/2. And sine is equal to 1/2 at pi over 6. So this happens at theta equals pi over 6. And so the way we would get that area is I'm going to double the area from pi over 6 to pi over 2. And in polar, we will do the graph that's furthest away. So that'll be the distant one, that's R of theta squared, minus the one that's nearer, that's 1/2 squared d theta. You can also do that in 2 separate antiderivatives. You can also take advantage of the fact that we're factoring in a semicircle, or the area contained by a circle, and you can use sector area as well. This is how I like to do it. Does the question actually want the area? It does indeed want the area. So now I'm going to open up my calculator, and the 2 times 1/2 will cancel, so I need to do the antiderivative from pi over 6, pi over 6 to pi over 2 of r of x squared minus 1/2 squared. I think that's 1/4, but what if it's not today? 1/2 squared dx. And I am getting ugly. Please don't write that on your AP exam. I'm going to go decimal. 2.0667 is what I got. 2.70667. And there is my answer for A. I think that's right. I'm also going kind of fast, so it's very likely I'm making a mistake here. Okay, number C. It can be shown that dx d theta is that thing. Find the value of theta that corresponds to the point on the curve C that is furthest from the y-axis. Furthest from the y-axis. Do they give me an interval from 0 to pi over 2? So we're looking at the right side of that. The point that is furthest from the y-axis is going to be like this point right here. And we're looking for that x-coordinate. When you're furthest from the y-axis, that is going to be when your x-coordinate is at a maximum. So we want the maximum x value. Wait, what do we want? We want the angle that corresponds to that. But I'm still looking for the maximum x. And if you want the maximum of anything, you want that thing's derivative to equal 0. So I need x prime of t, or theta, to be 0. And they gave me an expression for x prime. That is really ugly. We have to be careful punching this in the calculator. So I'm going to go to my calculator. I'm going to go to my graph. And I need to graph this. So 4 sine x cosine x squared minus 2 times sine x cubed. 4 sine cosine squared minus 2 sine cubed. Enter, and we're going from 0 to pi over 2. So I'm going to change my window settings. 0 to pi over 2. And we have one critical number, and that is at, okay, yeah. So menu, analyze, intersection. No, not intersection. Can I grab the x-axis? No, escape. I need the zeros. Menu, analyze, 0. 0.95. I'm going to, do I need to store that? No, I don't think so. So 0.9553. Theta equals 0.9553. And how do I know that that is a maximum? I know that that is a maximum because I'm looking at the graph of the derivative right here, and I can see that this derivative graph changes from positive to negative at that x coordinate, or theta value. And so I will put that in writing. This is going to get kind of wordy because I want to be thorough in my explanation. So what is it? What is the symbol for theta? Okay, so on Titan, I had to search for the theta symbol to type it in there. So we're looking for the maximum x coordinate. Okay, so I just realized that I paused the recording and never resumed it. So there's my explanation. I just typed that. Hopefully I only missed the typing of that. But I am looking at the derivative graph, and by looking at the derivative graph, I can see that x prime changes from positive to negative. That was the location of a maximum, and so I just put in words how I know that that is the location of the maximum. And I am good with part C. That's really wordy, really, really wordy. Okay, number D. A particle travels along curve C, so that d theta dt is this. Find the rate at which the particle's distance from the origin changes. Okay, the distance from the origin is r. That's what r is. This is with respect to time, when the particle is at the point when theta is. Okay, so this one's wordy. It's not going to be too bad to finish if you know what to do, but it's kind of a wordy question. So the question's asking for the rate, the distance from the origin with respect to time. So we are trying to find dr dt when theta is 1.3. Okay, well, if r of theta is, I don't need the expression. I was debating whether to write the actual equation. So dr dt is the same thing as dr d theta times d theta dt, and at theta, do they give me a t? Theta equals 1.3, so dr dt when theta equals 1.3 is going to be r prime of 1.3, and that's from the dr d theta, r prime of 1.3, times d theta dt, but they tell me d theta dt is 15. And oh, you know what? Is that what we did in part A? Hey, how nice of them. dr d theta at 1.3 is my work from part A, and so I can import that answer of 1.031. And so the answer is going to be 1.031 times 15. And I don't care what that equals. I'm going to leave it like that. And there's all my work for question number 2 of the AP Calculus BC exam from 2025. Again, if there are any mistakes or any suggestions or comments, let me know, and we will move on to question number 5.